Okay, hi guys. So in this lecture, we'll be seeing the mechanism of Wolf-Kishner reduction. So in the previous lecture, we actually discussed about the Clemenson reduction and Wolf-Kishner reduction, but we were only able to see the mechanism of Clemenson reduction in the previous lecture. So in this lecture, we'll be also seeing the mechanism of Wolf-Kishner reduction. So we had a compound like this, a ketone, and then we were reacting it with reagents called NH2NH2 and in basic medium. Remember that in Clemenson reduction, we used uh, zinc amalgam and sodium amalgam in presence of acidic medium, but here we are using basic medium. Okay, so please remember this important fact in mind. And then what would the reaction look like? This NH2NH2, the lone pair on one of the nitrogen atom would actually attack on the partially positively charged carbon atom here, and we'll get something like O minus and N plus H2 and H2. So what will happen is O minus will actually attack on the hydrogen atom of the N plus part, and we'll get something like this compound. Okay, now next what will happen is, again the lone pair on nitrogen atom would actually again form the bond pair with this carbon atom, and as a result OH minus would be leaving this carbon atom, and as a result it will also be taking H from the hence formed N plus atom or ion. So we'll get double bond between this and NH2. So now next what will happen is uh, so now what will happen is, we are again passing it in presence of a strong base. Then that strong base will actually take away the hydrogen from the nitrogen atom, and as a result we'll get a negative charge on nitrogen atom. Okay, and it will create a this conjugating structure, and we'll get negative charge on carbon atom and double bond between N and H atom. Next what will happen is, again this negative charge will actually attack on the water molecule to convert itself into this compound, where we will have something like N double bond NH, and again OH, a strong base, would actually make things easier for the nitrogen, these two molecules, to remove as a nitrogen gas. Okay, and as a result we will get a negative charge here. Negative carbon ion is formed and nitrogen gas is evolved. Okay, this again attack on the water molecule to remove one hydrogen molecule from the water molecule, and we'll get something like this structure. So this completes the mechanism of Wolf-Kishner reduction. Okay, this is the final product which is getting formed. Okay, so product is obtained in basic medium. Just keep this in mind, that product is obtained in basic medium, and in Clemenson reduction product was obtained in acidic medium. So product is obtained in basic medium. Okay, so please remember one more note in mind, that carboxylic acid will not undergo reduction by Clemenson and Wolf-Kishner reduction. Okay, carboxylic acids will not undergo reduction by Clemenson and Wolf-Kishner. Okay, so let's delve into the next example, where you need to convert one product into another. Okay, so you have been given something like this. Okay, OH attached here, and you have to convert it into this compound. Please remember that in mind, that alcohols, I have told you so many times that alcohols and ethers are stable in basic medium. Okay, so using this concept or this as a hint, you have to answer the following multiple questions that follows of this conversion step. So A part is, you can do this conversion using Wolf-Kishner reduction, using or using Clemenson reduction, or you can do it using H2Ni and this is a single correct choice question. Okay, so what would be the correct choice? This. Why? Because we need to provide a basic medium for alcohol and ether to be stable. Clemenson reduction, the product is formed in acidic medium, so as soon as acidic medium is introduced, it will convert itself into what? Water molecule will be evolved, and here it would have a carbocation. Okay, so H2N, because H2N can also make this compound, but can it make this compound? So this is an open question. I have explained this in my previous set of video lectures, so go and watch them, and also it would help you revise those concepts again if you still have a doubt in C option. Okay, so what I mean to say is, alcohols, if they are present in acidic medium, it will create a carbocation, and if they are present in basic medium, we'll have something like H2O formed plus RO minus. Obviously H2O is a strong acid than OH minus ROH, hence this reaction will not go into the forward direction and these products will not be formed. Okay, now let's discuss another example wherein we have something like this example. Okay, we have OET attached here, and we have something like the product formed is. So whether will you use Clemenson reduction or Wolf-Kishner reduction for this? Obviously you will be using Wolf-Kishner reduction. Okay, because the product would be formed in basic medium. If you introduce the acidic medium here, this will create a carbocation. This will again have some other things that will be following after the product is formed. Hence we need basic medium, and Wolf-Kishner will provide us the basic medium in presence of NH2 as the reagent, and KOH and slight bit of heating is required to provide the necessary environments. Okay, so if you have to convert this product or rather this substrate N plus Me3, we have identified this as a very good leaving group in our previous video lectures. If you are not able to remember those, just go and see the previous video lectures. Please do keep revising your organic chemistry lectures and videos, because these parts are very hard to remember, and you need continuous practicing and rolling your eyes over those concepts so that it feeds in your permanent memory. Okay, so for this conversion to take place, obviously you need some kind of reduction. Now whether you need Clemenson or Wolf-Kishner is the open question. So obviously you will be needing Clemenson reduction. Okay, why? Because you want the product to be formed in acidic medium. Why? Because once the products are formed in basic medium, what it will do is, the basic medium, the OH minus would actually attack on this carbon atom and form double bond here, thereby eliminating the strong leaving group. Okay, so we don't want that to happen, because in the product we actually do want NMe3 plus 2 hold back into the product side. Okay, so I hope you are now clear that if we use the basic medium, double bond formation would be there, but if we use the acidic medium, nothing would change, and the NMe3 group will retain itself in the product side also. So with this we come to the end of this lecture. In the next lecture we'll be seeing some more examples on the same concepts. So till then, good luck and goodbye.